I want to talk about the last of the three ways to solve a system of linear equations. The third way is to use what is called elimination. Elimination is sometimes referred to as solving a system using combination. So make sure that you're okay with those two words. They're interchangeable. Elimination and combination. We'll start by going over the 5 steps to solving a system using elimination. I've given you an example for each step so that you know what the step looks like. I'd like for you to write that down on your step-by-step notes. First, you want to arrange the terms in columns so that x and y and the constant are above each other. If you notice in the example I gave you, 4x and negative 2x are on top of each other. 2y and 5y are on top of each other. And the constants are on top of each other. I like to always solve them for standard form and then put them on top of each other. I think that's the most effective. Step 2 says multiply by a number so that the coefficients become opposites. Okay, you're just picking one coefficient. Okay, and you're just multiplying by 1 or 2 numbers to get that coefficient the same. So here I saw that 4x and negative 2x could be opposites if I multiplied negative 2x by 2. So I had to multiply the entire equation by 2, which left me with opposites, 4x and negative 4x. I could have multiplied this by 5 up here and 2 down here, and that would have made both of my y values 10. I think the easier way was to multiply the second equation by 2. The third step is to add the equations so that you eliminate, there's your key word, eliminate one variable. So if I add these guys up, 4x plus negative 4x, they cancel out. 2y plus 10y is 12y, and 6 plus 0 is 6. So when I solve for y, I get y equals a half. So the whole idea of multiplying an equation by a number to get opposites was so that this happens, the eliminating phase. Step 4 says to substitute the point that you just got, that y equals a half. Substitute that back into either equation and solve for the remaining variable. So in this case, I chose to substitute what I know into the first equation. Again, the instructions say it doesn't matter which one. And 2 times a half is a whole, and 6 minus 1 is 5. 5 divided by 4 leaves us with x equals 1 1/4. So you can probably guess what the 5th step is. That 5th step is to check your solution by substituting both coordinates into both equations. So this is what we think our solution is. So once I plug the solution 1 1/4, comma, a half back into both of the equations, it checks out. 4 times 1 1/4 is 5. 2 times a half is 1, and 5 plus 1 is 6. And then negative 2 times 1 1/4 plus 5 times a half, that's negative 2 1/2 plus 2 1/2, that is 0. That is also correct. So those are the 5 steps for solving a system using elimination. Let's try it with some practice problems. Our first practice problem says 4x plus 3y equals 16 and 2x minus 3y equals 8. If you recall, step 1 says to line them up so that the x's are on top of each other, the y's are on top of each other, and the constants are on top of each other. This has already been done for you since the x's are on top, the y's are on top, and the constants are on top. So we can go ahead and progress to step 2, which says multiply by a coefficient so that you get opposites. So if I multiply by 1, I can already see that positive 3y and negative 3y are opposites. So there's really no need to do any manipulation. It's already done for you. So 4x plus 3y equals 16 and 2x minus 3y equals 8. The next step says to add in order to eliminate. So those cancel out and you're left with 6x equals 16 plus 8 is 24. Then it says to solve for your variable. That tells me that x equals 4. Then if I plug in to get the other variable, just for ease, I'm going to choose this equation, the first one, 4x plus 3y equals 16. I'm going to plug in x equals 4, so that's 4 times 4 plus 3y equals 16. 4 times 4 is 16. 3y would equal 0. That means that y is 0. So we think 4, 0 is the solution to our system. The last step tells us to substitute back into the original equations, both points, to determine if we are correct. So if we take the first equation, 4 when x is 4, plus 3 times y when y is 0, 4 times 4 is 16, 16 plus 0 is 16. That checks out. And then the other equation, 2 times x when x is 4, minus 3 times y when y is 0, equals 8. 2 times 4 is 8, minus 0 is 8. That also checks out. So our point, 4, 0, is the solution. That is where both lines intersect. On to practice problem number 2. Step 1 says to line up your variables. Again, we've got x's on top, y's on top, constants on top. So step 1 is good. Step 2 says to multiply by a constant such that two coefficients become opposites. So I've got two choices here. I can eliminate the x's or I can eliminate the y's. Both of them are just as difficult to get rid of. I'm going to choose to multiply this by 4, that 4 right there, and I'm going to multiply this equation by 3, this 3 right here, because 3 times 4 is 12. So 4 times 3 is 12, 3 times 4 is 12. Those will cancel out. I'm going to get 12x plus, and don't forget you have to distribute this to every term, 20y equals 24. And then I'm going to get negative 12x plus 6y equals 15. If I add these up, 12x plus negative 12x, those cancel out. I get 26y equals 4 and 5 is 9, 2 and 1 is 3. 39 divided by 26 is going to leave me with y equals 1 5/10. I need to plug this solution back into either of the first two equations so that I can solve for the x value. Three x plus 5y equals 6. I'm going to choose the first equation, and I'm going to plug in when y equals 1.5. So I'll get 3x plus 5 times 1.5 equals 6. 5 times 1.5 is 7.5. So I have 3x plus 7.5 equals 6. If I subtract both sides by 7.5, I'm going to get 3x equals negative 1.5. And then lastly, if I divide both sides by 3, I'm going to get x equals negative 1/2, or negative 5/10. So we think that negative 5/10, comma 1 5/10 is our solution, but we do have to check it. So we're going to check this point with both equations. That's 3 times negative 5/10 plus 5 times 1 5/10, and that's supposed to equal 6. If you have negative half 3 times, you have negative 1.5. And remember that 5 times 1.5 was 7.5. So 7.5 minus 1.5 is 6. So that one checks out. And the other equation, negative 4 times negative 5/10 plus 2 times 1 5/10 is supposed to equal 5. 4 halves is 2. Negative times a negative is a positive, so that is 2. Plus 2 times 1.5 is 3. And 2 plus 3 equals 5. That also checks out. So our solution to this system is negative 1/2, comma 1.5. On to practice problem number 3. This is the first equation you've seen so far that is not already lined up. The x's are not on top of each other. The y's are not on top of each other. And likewise, the constants are not. But if I take this guy and rewrite it in standard form, I could get the top equation, and then I would get 5x plus 2y equals 12. Since I have a 2 and a 2, it seems as though I could just multiply by negative 1, and those would give me opposite coefficients. I would have 3x plus 2y equals 8, and negative 5x minus 2y, there's your opposites, equals negative 12. So I need to add those together. 3x plus 2y equals 8. Negative 5x minus 2y equals negative 12. 3x minus 5x is negative 2x. 2y plus negative 2y, those cancel out. And 8 plus negative 12 is negative 4. If I divide both sides by negative 2, I'm going to get x equals equals 2. If I plug this back into either one of my equations, 3 times 2 plus 2y equals 8. 3 times 2 is 6. 8 minus 6 is 2. So that leaves me with y equals 1. So I think my solution is 2, 1. But remember, last step is to check. So let me check the solution. 2, 1. My first equation was 3x when x is 2 plus 2y when y is 1. That's supposed to equal 8. 3 times 2 is 6 plus 2 is 8. That checks out. And my other equation was originally 2y, so that would be 2 times 1 is supposed to equal 12 minus 5x when x is 2. So that's 2 equals 12 minus 5 times 2 is 10, and 12 minus 10 is 2. So that also checks out. So 2, 1 is the solution to our system. That is where the lines will intersect. Another way of saying that is 2, 1 satisfies both equations. All right, for practice problem number 4, I'd like for you to pause the video and you try applying the steps. First, remember to line up in columns your x's, your y's, and your constants. Then, see if you can multiply by a number so that two coefficients become opposites. Add up your equation. Substitute back in to find the missing variable. Then check yourself. When you've got a solution, come back to me. Okay, let's see if you're right. First step, line up your variables. We're lined up there. Second step, I chose to multiply by 4. I was eliminating the x's. Now you can just as easily multiply one of the equations by a negative 1, and that would eliminate your y's. Totally doable. When I multiplied by 4, I got negative 4x plus 4y equals negative 16, and 4x plus y equals 26. That canceled out my x's. Then I was left with 5y equals 10. So you can see that y equals 2. If I plug that back into one of my original equations, you can see that negative 4 minus 2 is negative 6, divided by a negative, x equals 6. Then the last step was to check to see if 6, 2 was the solution. So I plugged a 6 and a 2 in for x and y. Negative 6 plus 2 is negative 4, so that one checked out. And 4 times 6, 24, plus 2 is 26. That also checked out. So 6, 2 satisfies both equations. I'd like for you to complete your step-by-step notes. Then summarize how to solve a system of linear equations using elimination. If you have any questions, it's important that you write those on your note packet so that I can answer those in whole group. And when you are done with that, please take the 3-question Edmodo quiz.